Okay, so this video, I think it's important to make because it's a problem that this is the first time I've come across it anyways. I had a customer send me a machine from eBay. He purchased the listing going back to May 8th. And at the time he wanted a hard drive. He bought this particular Xbox One without a hard drive. And sorry about the lighting here. And I basically, as soon as I got it, I built the hard drive, got the system up and running. Not to get too into the details, but right away one of the things I noticed was that there was some video issues. Now when you have an Xbox One without a hard drive, it'll usually just display a black screen. So it's unclear when you get a machine without a hard drive whether or not there's anything actually wrong with the video or it's just the hard drive itself. So I was able to build the hard drive blind, meaning I formatted the hard drive, I put the OSU one on there and left the machine running for a couple minutes and wasn't getting any video output, but I just sort of let it do its thing. I then switched some HDMI cables. The short of it is I was able to get the machine to show some video on a particular monitor, actually my Samsung monitor here, as opposed to my my BenQ monitors over there. I couldn't get any video display on those. So it seems to, depending on the system and how well it handles the HDMI or poor HDMI signals, you might get some output, you might not. And I'll show some video of what this machine was actually doing. It was showing a lot of artifacts. The video kept resetting, and I think that's basically the majority of it. But or just no video at all. On certain monitors, it won't output anything at all. On this monitor, it does load up, but you can see here there's a bunch of artifacts here, and you can see it here as well. And the image will go in and out, so I'm gonna load up a game here. Okay, actually here, let me, yeah, do you see that artifact stuff kind of going back and forth? Now occasionally, so I'll go back to, yeah, there, right there, video reset. Okay, see all that crap on there? And reset again. I've never really seen anything like this before, so I'm going to send you, this is at 1080p, so I'm going to send this video to you right now. See, it just keeps resetting. Depending on, so if I get back out, it's a little bit better. There you go, actually it's not. So if I go into settings here and I change the video output to 720p, you see that there? You can change it to both. I'm going to go back here into the same game, and you can see there's no artifacting at all on the screen. And I'll hit resume here, and you can see everything's fine. It doesn't reset. There's no artifacting at all. So at 720p, everything's fine. It's at 1080p, it starts to act really weird. I've never seen anything like this before. I thought maybe it was the port. I replaced it, didn't change a thing. I was able to see the picture well enough to know the hard drive itself wasn't a problem anymore, but there was some sort of video output issue. So you can see here there's actually two different HDMI ports on here. I don't know if I get a close-up of that. There are two different brands. You have your HDMI out port here, or your HDMI in port rather, which you know, it's not a port that anybody uses, and I've never tested on this system. But here's the actual one that everyone does use, which is the HDMI out. And this has actually been replaced because initially, if you look online for the type of video problems I was seeing or were displaying, it's recommended to change the HDMI port. Now physically the HDMI port looked fine, but I figured, you know, it's something I hadn't done before, so it was worth trying. So the customer was willing to wait the week or so. I think it took a couple weeks. Well, it took about a week to get the part in and a couple more days to actually get the part installed. But and this is actually extra one of them. I spent, I think it was $10 for the listing, and you get two HDMI ports. And you can see here, there's 19 pins on the bottom. It isn't an easy thing to solder. And later on in the video, I'm going to actually show the process of replacing this port. I used a standard soldering iron. I didn't use a hot air workstation, and I was able to replace it. I also used a rotary tool to cut away the metal. You'll see all that later in this video. Anyways, I replaced that port, and it didn't change the output issue at all. In fact, at that point I wasn't even sure what to do, but one of the channels I'm subscribed to is an Andrew Paul, and he does a lot of console repair, particularly PlayStation 4 and Xbox One repair. And he had pointed out an issue with the Emi Esd Filters. basically the ESD stands for electrostatic discharge. So basically on these HDMI ports, there's these little filters. You can see them. They're actually, yeah, they're ESD EMI filters. So the electrostatic discharge. So they go right from this outlet. There's nothing here, but they're just basically the cable runs from here to these ports, and they run to the video chip of the Xbox One, and they prevent basically shock or a surge from the TV destroying the video board of the Xbox One. And you can see here, this actually works pretty well. You can see here on the input port, this the silver solder points here. This is actually where I removed the ESD filters from this port here. And Andrew Paul shows you how you can test this. Basically what you want to do is you can continuity test. They are considered 4-channel filters. There's 2 channels on the other side and then ground in the center. So essentially there's 10 pins. This is actually a straight through connection. So the ESD filter just sits on the EMI ESD. Electromagnetic interference is the other thing they do. So they help with any kind of interference either coming out of the Xbox One or coming back in to the signal and messing with the signal. And they're actually straight through connections. So you can remove the filters and you'd be fine. The only issue is now you're not protected against electrostatic discharge, and you could potentially ruin some more important parts in the system later on. Anyways, so that said, I removed the filters and all the problems went away basically. The artifacts went away and the video going in and out went away. So the next order of business was to actually get some replacement parts, and I'll link them in the description of this video. I got them from Mouser. They're super tiny. I'm gonna put in some photos, but that's the guy right there. You can see how tiny that is. I bought a strip here of 20 of them. They run about 55 cents on Mouser, 56 cents. I think it's like 55.5 cents, something crazy like that. So it cost me about $10 for this strip and then another $5 to ship. But with one strip of 20, I can fix 10 Xbox Ones with this particular issue. So I will be offering that service on eBay for anyone that's having, and again, I'll show you later in the video the type of issues I'm having, but anybody having video output problems, this is potentially a fix. I can replace the HDMI port's only about $5, and like I said, I had to replace both filters because they tested poorly, and that's about $1 worth of parts. Okay, so the only other thing to mention, Andrew Paul tests these things, but the basic thing to know is that the channels, there's 4 channels, and I'll show you in the picture where the channels are. But basically, there's 2 outside channels, a center ground, and then, well, 2 left side channels, a center ground, and 2 right side channels. And the channels themselves should be independent of each other. And when you do a continuity test, if you see continuity between any of the channels, then it's a bad filter. Basically, it should be top and bottom straight through should have continuity, and then the second channel top bottom. But you shouldn't have left and right. It's hard to explain, but and it's hard to also show you because I don't have a great camera for it. But I'll link you to Andrew Paul's video on how to test the filter. I don't think most people are going to be concerned with that. This isn't something that everyone's going to want to do, and you'll see when I change the actual HDMI port that it requires quite a bit of cutting and soldering, and I use low melt solder to get those back pins off in the back there, if you can see that. And yeah, you can see the 19 pins that I'm referring to there on the back. And I basically use some low melt solder to get those off and then cut around the metal to get the top of the sheeting off. Anyways, I'll show that in later video. So what I'm going to do now is I'm actually going to solder those tiny little filters on those points right here. So you'll see in a little bit those 2 filter on. Basically, I'm going to drop them down, and I'm going to show you again pictures of those particular filters. They do have they have soldering points on the outside edge and also on the bottom. So if you apply a little heat to the edge, it'll solder down okay. So it's a little bit tricky because they're really tiny, so I'm going to need my magnifying glass when I'm actually installing them. So for the setup I have now, it's almost impossible for me to film it, but I will show you the end result and then show you what the video looks like as a result, and then get this shipped back to the customer. Because like I said, I've had this since May 8th, and today's date is June 19th. He's waited for a lot of parts, And now that I have the parts in stock, I'll be able to do this whole process a lot faster. I need to get some more HDMI ports, but I'm going to stock up to be able to handle at least 10 systems going forward, and maybe even purchase a few broken video output systems and fix those and then sell those on eBay as well, just to keep less systems or more systems on the market. There seems to be, I don't really care about the market, but I guess it does bother me that a $1 part will basically mean that people are trashing systems for such a small issue. All right, anyway, so I'm going to solder them down and come back and show you the end result and show you what the video looks like. I just want to throw this in there as well. So I have these screw kits I bought. I bought a bunch. I got a bag of them. I think I bought about 50 of these or so. But I'll put a link in the description. But these bolts basically allowed me to, this system was missing a hard drive, didn't have any screws. And these screws are great because you need a certain length. You can see how long these are. I guess these are 8mm screws. You need a certain length to be able to properly attach the hard drive to the board here. But also, these are hex bit screws, so they're the same as the rest of the system, so they match the Xbox One. Anyway, so I got a bunch of these screws as well. I have screw kits to replace other things inside the Xbox One as well, because I get a lot of these systems and they're missing screws, so I do that stuff as well. So if you send me your system, I can replace any screws that might be missing. So I just wanted to point that out. Again, the link will be in the description. Okay, so this is the two parts here soldered on. You can see this is the same board. This is before I put it together. I just wanted to show you. So we have the two different ports here still. And as you can see, it's the same board. And used two of these guys here. And so we're going to keep I'm going to keep my fingers crossed that this resolves the issue. I don't know if you can see the labeling on the chip there, but anyway, so the next thing to do, this is completely stripped down with the exception of the heat sink and the fan, just to be able to get access to that. I will say these are not easy to solder in. They're very tiny, and the soldering iron, at least the one I have, is ginormous. It's really big, so it's hard to get in. You basically have to run a ton of solder across, not a ton, but you put a good amount of solder on the end of the soldering iron and run it across all the pins, and do that several times, and it'll get enough solder in there. There's a tiny little bit of pad showing on the left and right side of these chips, and you can get some to attach. So I would do that, and then with the flux, I have some flux here. I use flux to keep everything nice. But a result of that, you have to clean it up, check the pins. So you wind up having to run it across a few times, unless you get lucky and the solder sticks for you really easily. But there's such a, I can't stress enough how, so I'm trying to look into, this soldering iron barely fits in there. So you gotta be careful about, you don't want the chip to move, you want to keep the chip centered, so you can't apply too much pressure. Anyways, it's quite a bit of work, but as you can see, it's all set here, so we're going to get the system all back together and keep our fingers crossed that everything works okay. Okay, so we got everything hooked up here, and we're going to start it up for the first time with those Emi Esd filters attached, and we'll try to capture boot here. See if we can get an idea of the video quality. I don't know how well it's going to come on the camera, but I can tell you right now, looks good. The system works without the ESD filters, so it's difficult to know if the new filters are doing anything at all, really. The picture looked just fine. That said, that they're there for ESD, electric static discharge protection. So as long as they're soldered in okay, they should be fine. But one thing they shouldn't be doing is creating the interference and creating artifacts on the screen, which they were doing. And don't see anything on the screen here. Let's see, I might try to. Already, I don't see any sort of artifacts on the screen, and let's see, I should load the game. see it's coming up okay. I don't know if I have. Oh, you know, one more thing I will show you. Well, hold on a second. I got to get the controller synced, but I'm missing the thing behind the sync button, so I can't actually sync a controller. I'll be right back. Okay, all right, so we got a controller synced here. And right now you can see the picture's okay. I'm not actually going to run through the game. I'm not seeing any artifacts. It hasn't reset once. But what I did want to show you guys is the is in the settings here. Now I don't know what order I'm going to show you the process I went through with this system. But what I do want to show you is the current video settings. You can see it's out 1080p output, and those are all the settings. So what I will probably show you after this is some of the issues that we had, and one of the things that I was able to do was run this in 720p mode, and when I did that, it actually was better. The picture was more stable. So those filters cause a lot of strange issues. And for anyone that wants to send their system to me for this repair, I have certainly no issue doing it. But I will say I probably won't go through the process of fixing the HDMI port first unless I can see some physical damage. And what I'll probably do is actually test end-to-end first, just to save the time there. Like I said, it was such a common thing that people seem to be doing. I really did think it was the issue with this system. And wasn't exactly sure how to troubleshoot it, but figured, well, we'll make out the swap anyways, which we did. Turned out to not help the situation, and it is a lot of work to do. So you want to make sure you're replacing the easiest, or going through the easiest process to get the solution. So anyway, so that should conclude this. The system's finally ready to go to the customer. At this point, got a new hard drive, got the LED changed, got some new ESD filters, and a new HDMI port. Okay, so what I have here is a system that was sent to me that needed a hard drive. The person who purchased it bought it without a hard drive. And I've actually done all that. They also wanted me to change the LED on the front to green. And I've got the hard drive installed and everything up and running. But what this video is going to be about is the fact that we need to replace the HDMI ports. These are a couple of HDMI ports I got on eBay for, I ordered 2 for $10. And what I'm showing you here is how tiny. There's 19 pins on here which need to be soldered. And then there's 4 pins that hold the actual port itself down to the motherboard. And these help secure it so that these pins on the back don't get ripped out. So what I'm going to do now is I'm going to strip this system down all the way to the board, and we're going to remove the existing port and get ready to replace it. I haven't actually done this before, and I have kind of a crappy setup here. I have a soldering iron that's a direct plug where I don't have a lot of control over the temperature. I do have it hooked up to a dimmer here where I can control the voltage. And but this particular iron gets really hot. It gets over 1,000 degrees Fahrenheit, and but typically you want to run it between 500 to 600 degrees Fahrenheit. That's about the melting point of most solder, particularly leaded solder. And I have another guy here, which is a solder sucker. It has this little bulb. You squeeze it. It itself is also a soldering iron. So I have a couple different tools here. I have a desoldering braid. And then I also have a, this is actually the box here, but I also have this little drill master kit I got from Harbor Freight for about $10, and this allows me to cut metal. So what I might do is cut some of these legs off of the port and then desolder this here. I have some low melt solder. I'll bring that out in just a little bit. In fact, here, let me see if I can grab it really quick out of my bag. Yep. Here it is. So it's some SMD Removal kit, it's called, but this is low melt solder. And the idea is we'll put this on these little pins on the back. And because it's a low melt, it stays in a liquid form for a longer period of time than normal solder. So it's enough where you can basically liquefy all the solder on all 19 ports at once, and the port just falls off. And you would do this mostly if you didn't have a hot air system. There's a channel I watch a lot this guy, I think his name's Andrew. I'll link him in the description. He actually does a really good job of replacing these ports, and he uses a hot air iron or hot air. I don't know what the right term is, but he's able to remove all 4 pins and the 19 pins all at once just by heating everything up. The port basically falls out. It's pretty amazing. But I don't have one of those, so I'm going to try to use what I've got. Okay, so here's the system completely stripped down. I'm going to replace the thermal paste as well. May as well when you take the board apart as much as this. This is the actual HDMI output port we're going to replace. It's snug right up against the power, and this is the, what's it called, the fiber audio out. I forget what it's called. But so it makes it a little harder to get at the actual port itself. But we can see here on the bottom, the main thing we're going to want to concentrate is getting the solder out for these 4 pins here. What I think I'm going to do is put some leaded solder on here, and maybe I'll show that really quick and then see if I can solder suck all this out. If I can't do that easily because I'm unable to get enough heat to remove that solder, I will probably switch to using a cutter, and I'm going to cut these connectors as much as possible here. Again, because of the location of these 2 ports, it makes it more difficult, but it's going to be worth a try. But the main idea is to get these 4 ports separated first, and then we're going to use our low melt solder to take off those or to undo those 19 pins in the back. With the low melt solder, we also have to be careful with that as well. You can see there's a couple chips in there. I don't know if you can make that out, but they're very close to those ports, and the low melt solder goes everywhere. So it would very easily remove these components as well. Looks like there's some tiny capacitors, and there's enough room, but you just have to be very careful in doing this because you could make the situation worse very easily. This is not something I recommend for the average consumer, but there are plenty of people that will do this for a fairly low price. I'm actually doing this as part of my service, but this isn't something I normally do, especially if this goes well. I will charge separately for this process, but and especially it's a difficult thing to troubleshoot. What I showed you there was some of the issues that I've been seeing, but they differ a lot depending on the system itself. But this is a fairly common thing that's done, which is replacing this port. So I'm going to let's see. I guess what I'll do is I'll film what I try here, and then I will cut out the bits that are kind of a waste of time. All right, so I did try to do some desoldering, and with the desoldering wick and the desoldering bulb here, and it was having a real difficult time cutting through. That said, I did manage to loosen this up a bit, but what I've decided to do is use this here. In fact, here, let me get this thing off. It's a Drill Master by Harbor Freight. It cost me about 10 bucks, but I have this little cutting blade on here. Oops, here we go. It's a little cutting blade on here, and I'm able to cut through. I'll show you a quick example here. What I'm trying to do is cut through the top metal here, and just very gently. Let's see where that is on the camera. Yeah, it's not too bad. And just cutting through the top of the shield here where I can. Yes, I've already disconnected that. So I'm just trying to, like I said, separate out this feet, but I don't have much of an angle to work with here, so I'm having to cut through the top first, and I'm going to bend it out a little bit and see if I can get some of the cuts in further. It's slow going, but it does get through. So I'm going to cut back in a little bit when I have it cut enough where I'm just going to desolder and take out the pins, and then I'll do the last part, which is getting those 19 connectors out. Okay, we'll come back in a second. I'm going to finish cutting the rest of this top. I'm going to show you how it's already pretty loose. There we go. so this top part comes off, and that should reduce the amount of heat that cuts through, and we can actually see the connector itself now. Like I said, physically it doesn't look like there's anything wrong with it. Okay, so at this point I've got the pins completely cut and independent. I used a combination of these little clippers here to cut away the metal, the sheet metal. I bent it back, as you can see here and there. I'll show a close-up when I finally get this thing off. And I used my clip nippers here. Any kind of tiny little metal cutting thing. These are usually for wire. They're not as good for this kind of sheet metal. You can see I'll blow I got to clean all the stuff off. But basically, at this point, the underpins are not holding this on anymore. So I already have the low melt solder on there, if you can see that as a strip. So I should be able to just solder, and then that should pop right off. So we'll do that right now. And again, you know, the thing I'm most worried about is these pins, because if you damage them, you're in trouble. But once you have everything off, it's a matter of just putting everything back down again. It's a bit easier to put back on than to take off, because you can set the new port without having to worry about, you can basically solder down these 19 pins before you solder down the thing that actually holds it in place. All right, anyways, we'll see actually how that goes. I have the soldering iron ready to go here, and let's see if it's enough to get this port off. So you can see that low melt solder there is working its magic. Go, keep going here. Seems to be walking. Still a little bit of there we go. Okay. There we go. So that's the port off. Now I got to clean these things up a little bit. I'm going to put some stuff down. I didn't apply any force there. I kind of pushed backwards as I was with the soldering iron. I kind of went back and forth, and it just let it naturally fall off. Because now we got to get all this low melt solder off of this thing, because it won't be a great hold here. Let's see. I'm going to use desoldering braid here again to remove that remaining glob of solder. And then I'll have to finish taking, I'll use this to remove the rest of the stuff, but I got to finish taking these little bits off, which we're holding the port on. But we should have a clean surface now to work with to adding the new HDMI port. And I did all that without a hot air gun, with a $10 Harbor Freight drill. The Harbor Freight drill just definitely came in handy. In fact, the biggest hurdle for me thus far has been just the fact that the vicinity of these two ports here has been a bit of an issue, but there. Okay, now I don't know if you can easily see that, but there we go. And you can see, so you can see straight through the holes now. But now it looks a little burnt. That's the flux. So after, I forget where I left off, but I had the pins left in there, and basically I put the board on its side, used the pliers, pulled, and just applied heat, let it sit for a little bit, wiggled, and pulled it out. And then once I get all those out, then it was a matter of actually clearing out the holes here for when we put the new port down. And to do that, put a lot of flux, use your desoldering braid, and keep going. The flux will cause the solder to melt easier, and it'll adhere to the desoldering blade easier, so braid. And I did the front side, put flux on the front side, and I did the back side, put more flux, and went back and forth until eventually, basically, put this down, applied the heat, rolled it, and pull it off, and it would take a lot of the solder away. And if it's not working for you and you're leaving it for 5 to 10 seconds, it's still not coming off, add more flux and do it again, and you'll eventually get there. So at this point, the hard part, as far as I'm concerned, is done. It's still going to be a pain in the butt to solder all those pins down and not have them bridged. Again, if they do bridge on you, you're going to have to, the trick there is to not apply a lot of solder, put a lot of solder on your soldering iron, have the soldering down on the pads, and then just independently do each one. You're still likely to have some bridging there. But again, that's a matter of using a lot of flux, which will help to the solder to stick to the surface that you want it to, and where you have the gaps, it'll basically separate from the gaps. So you're not going to want to use a lot of solder there. So what I'm going to do now is I'm going to clean this up really good so that there's no flux on it, so that it's a nice surface for applying. I'll actually put fresh flux on when I'm resoldering, but you can see it's all burnt and it's crap in there. So we're going to clean that off. And we do that with, like I said 1,000 times before, is some rubbing alcohol. I usually use 90%, and put it on a Q-tip and then dab it a lot. It takes some work to get it off, but and you basically just run it across here. So I'm going to do that next. Clean up my workspace because I have dust everywhere, and get ready to actually solder down the new port. I got to clean up my pad here. It's just a mess. You can see all the dust and stuff from cutting, but definitely cutting around. This is what the port looks like now that it's been cut off. The entire top metal's off. I basically eventually cut the legs off, pushed it down, and you can still see this is low melt solder still on those pins there. But there you go, that's the old port. So hopefully this does the trick. It's a lot of work to replace one of these. If the problem is still a problem, at least we made an attempt at it, and it cost me a lot of time, but not a lot of money. All right, anyways, so we'll get back after this cleaned up, and we'll start working on getting the new port soldered in. Okay, so I used some rubbing alcohol to clean this section of the board up here. Let me move this out of the way. I used some canned air to blow off all the dust and everything, and really clean this down really good. So we have it. So we have a clean port surface here. I used some flux and a little bit of solder, ran it across again, and then cleaned it up with the desoldering braid again. I'm not sure what it is. Oh yeah, here. So I do have just a smallest amount of solder on these points, and I have all the holes cleared out. On the actual new port that I'm going to be adding, I put some flux on here, ran a little bit of solder. Ran a little bit of solder across that as well, just the tiniest amount, and then cleaned it, and then put a little more flux on again. So I'm not going to add any more solder to these two sides. There's already solder. They're both tinned basically on both sides, so they should have enough solder to hold. You don't want much anyways. It's a very small connection. You just want them to make connectivity. So what we're going to do here is, with the holes cleared out, we're going to just pop this guy right into place here, and we're going to put all of our legs in and then push it down, and we'll see on the other side here that you can see the legs popping through here, but also there's plastic on the bottom to show you what I mean. The plastic, or this black part, actually makes contact with the motherboard, and the metal comes through. We would solder these pins down to hold the port in place, like that. We'll do that in a moment, but we want to make sure that this sits flush. I think I can see that right there, but you can see it sits flush, just as it does here. And then with a magnifying glass, now we got to go through and just check that they're all pushed down, and we're going to just apply a little bit of heat across all these pins here. And I'm not going to add any solder, because if I add solder, it's likely that I will start bridging connections, and with how tiny they are, it's going to be a real pain. So at this point, I want to have a pretty clean soldering iron and just run it across the bottom there. Okay, so let me get try to fix up the lighting here. I took it off my upper holder there so I could get in close and show you everything. But I cleaned off the process here, got all the paste off. And the actual thing here is the HDMI port. Now, let me see, I think maybe going from this angle. See if we can get in there. Yeah, that's about right. But I have a tiny, I have this thing here. It's hard to see here. Basically, I have, what's this called? Tweezers. I have these tiny tweezers, and you go and you check each port. So basically, you run the soldering iron across all 19 connections there. And then I would go through and test each individual connection and move it a little bit, see if it would move. If it did, I'd go back and I put the tiniest amount of solder on the end of my soldering iron and soldered it down again. It took quite a few passes to get each connection soldered down properly. And again, I didn't bridge any of these, so I didn't have to go back and do things more than once. Sorry, I'm shaking a bit. I haven't had enough coffee today. But, so here are the two. Here, let me see if I can fix it. Lighting is a constant issue here. If I had a real production, it would be fantastic. But I think you can see that there. There, that's probably the best way to, there. So you can see both ports side by side. So this one to the right, this is your HDMI in, and this is your HDMI out. And you can see they both look fine. On the bottom side here, we can see our newly soldered in port versus, so this is the, sorry, this is the HDMI in, and this is the HDMI out, as far as I know. Well, I never used the HDMI in, but I assume that was okay, but it doesn't matter. It isn't what the focus of this was. But here you can see the top. Clearly you can see these are the, this is the replacement port, marked by the FLK. And this is the original original port. So everything's soldered down correctly, and I just need to apply some soldering paste there, some thermal paste on the CPU, and get this whole thing basically put all back together again and try out our HDMI port and see how it goes.